And the very first property of this we're looking at is the multiples of a number. So generally, if we are talking about the multiples of a number, say x for example, then the multiples of this number simply means that we should multiply this number x by a progressive series of numbers. Okay? So the first multiple becomes 1x, 2x, 3x, 4x, and so on. Now what do we mean? For example, if we are talking about the multiples of, let's say, 5, then we are talking about what? 1 times 5, comma, 2 times 5, comma, 3 times 5, comma, and so on. So this implies that the multiples of 5 will simply be what? We have 5, 10, 15, and so on. That's what we mean by the multiples of a number. The second thing we're going to be looking at is simply the factors of a number. If we are talking about a certain number, say x for example, then the factors of x simply means that we should list out all the possible numbers that x can divide without a remainder. So for example, if we're talking about factors of, let's say 6 for example, that means we are going to list all the numbers that 6 can divide. So we begin with what? 1. 1 is a general factor to all numbers. So you see that 6 divided by 1 is 6, no remainder. So the second factor is what? 2, because 6 divided by 2 is 3. You see, no remainder. The third factor is 3, because 6 divided by 3 is 2 with no remainder. Now 4 is not a factor of 6, because if you take 6 divided by 4, it's going to leave out the remainder. So the next factor is that normally, remarkably, you have to know that whenever you reach midway of that number you're looking for, its factors, the next number just becomes it. Okay? So another example, we are looking at the factors of 10. Then we are going to start from where? 1 is a factor, 2, 3 is not a factor. The next factor is 5, and since we are midway gone, the next factor just becomes 10, and that's it. So we observe this now, when say that multiples are infinite, that means they continue up to infinity. Whereas factors go right, they are finite, that means they have an end. Okay? So that's it. So at this point, we're going to look at the concept, the principle of prime factorization. That's the third principle we're going to look at. Prime factorization. Now, what do we mean by prime factorization? If we are asked to express a number as product of its prime factors, it simply means that what? We should take that number and break it down such that at the end of the day we are going to have what? A multiplication kind of scale with respect to what? Prime numbers. So what do we mean? For example, if we were to express 30, for example, as a product of its prime factors, it simply means we should break down this number such that at the end of the day, we should have only what? Multiples of prime numbers, which is still exactly the same as 30. So what do we mean? You know that 2 can be written as what? 2 times 15. Now we see that 2 is already a prime number, but 15 is not yet a prime number. So we need to look for other 2 numbers that we can multiply to have 15. So what do we mean? 2 was already a prime number, but we know that 15 can also be written as 3 times 5. Not so? So you see that all of these numbers here now become prime. And this simply means we have expressed 30 as a product of its prime factors. Let's take another example, 24. 24 is the same as 2 times 12. 2 is really a prime number, but 12 is more than a prime number. So we have to break it down again. So this is the same as 2 times 12 can be written as 2 times 6. Also, now you see, these are only prime numbers, but 6 is not a prime number, so we need to break it down again. So you see that what? This is the same as 2 multiplied by 2. 6 can be written as 2 multiplied multiplied by 3. You see that all of these numbers now are prime numbers. But from your knowledge of indices or the concept of notation, 2 times 2 times 2, 2 has replaced itself 3 times. So it can be written as what? All of these can be written as what? 2 raised to the power 3 and then multiplied by 3. This simply means that we have expressed 24 as a product of its prime factors. Now, to this effect, we are going to already look at the concept of what? Prime factors. What do we mean by prime factors? If, for example, we are asked to find the prime factors of 10, the very first thing you should do is to be able to list out the factors of 10, which are what? 1, 2, 5, and 10. After listing out the factors of 10, you cannot ask yourself, which of these numbers here are prime numbers? The only prime numbers here are 2 and 5. And this implies that what? The prime factors of 10 are what? 2 and 5. These are not just the factors of 10, but these are the prime factors of 10. Okay? Or you can express the number as products of its prime factors, and at the end of the day, you copy the different numbers without repetition. This is the principle. So at this point, we are going to look at the concept of LCM and HCF. So what do we mean by LCM? What I'm going to do is I will make it very short and simple. I will work with the both of them at the same time so that you understand the principle behind each of them. Okay? So let's begin with LCM. Now, we are going to use an application build-up method, which simply means that we are going to use an example, which is going to say we are going to be looking for the LCM and HCF of 12 and 30. Okay? So, first of all, you have to know that LCM means the lowest common multiple. That means that if you want to look for LCM, we are going to be using two methods. So, let's begin with method 1. The very first method simply says that what? You have to start by looking for the multiples of each of the numbers. Now, remember, multiples are infinite. So you have to write in the multiples of 12 and the multiples of 30 at the same time. Okay? And at the point where a number repeats itself in one set that had already occurred, at that point you have to stop and that becomes the lowest common multiple. I repeat again. The very first step using this method is that you are going to write the multiples of the numbers 12 and 30 at the same time. And at the point where a number, let's say in this set, shows up that had already repeated in this set, or if a number shows up here that had already repeated here, you stop and that becomes the LCM. So let's go. So the first multiple of 12 is simply 12 times 1. The first multiple of 30 is what? You are writing all of them at the same time. When you write one up, you write one down. Okay? The second multiple of this guy is 24. The second of this is 60. The third of this is 36. Yeah. Here we have 90. Here we have 48. Here we have 120. Here we have 60. Now, automatically you see that 60 has occurred here and it has already repeated itself. It has already occurred here. So at this point you have to just end. And that becomes the LCM, the lowest number that is common between 12 and 30. That's the meaning of the LCM of 12 and 30. So at that point you just conclude and say that hence the LCM of 12 and 30 is 60. And that's it. Now, method 2, we are going to be very brief. Method 2 is the tabular method. That means we are going to use the table to work this out. Now, the first thing for you to do is to write the numbers. We have 12, we have 30, okay? When you construct these lines, you start by looking for any number that 12 and 30 can divide with without the remainder. For example, you can always begin with 2. 12 divided by 2 is 6. 30 divided by 2 is 15. Which other number can 15 and 6 divide with that remainder? You can think of The smallest number is 2, we take it out. The number that can divide 2 is 2 also. So we take it out. 2 divided by 2 is 1. Now 5 divided by 2 cannot go. Not so it's going to be a remainder. So you bring down your 5. Now note, at the bottom you have 1, it means the simplification of this line has ended. So you now focus on the other line. So you can just, the number that 5 can divide is what? 5. Not so 5 divided by 5 is 1. And this guy, since this guy already finished his simplification, you just need to repeat. And now at the end of the day, you now multiply all of these, you multiply all of them. So it implies that what? The LCM equals 2 times 3 times 2 times 5. You do that properly. 2 times 3 is 6, 6 times 2 is 12, and 12 times 5 is 60. That's the LCM. You see that in this method 1 we have the same thing. In this method 2 we have the same thing. Now to this effect, we are going to heavily look at the concept of HCF using the same example for better understanding. So I'm going to be looking for the HCF of 12 and 30 now. And we are going to begin with method 1. Method 1 simply says that what? We are looking for the HCF. HCF means the highest common factor. So that simply means that what? You're going to list out, if you're dealing with two numbers, let's say 2 and 30, you're going to start by listing the factors of 12 and the factors of 30. And at the end of the day, you look at the one, the one that is common, you look for the common factors. You list out the common factor set, and then now you look at the number that is the biggest, and that becomes the HCF. So let's do. So you are going to look for the factors of 12 and the factors of 30. So factors of 12, all the numbers that 12 can divide 1, 2, 3, 4, 6. When we made 1, we just have 12. Also, 30, what do we have? We have 1, we have 2, we have 3, no, 4 cannot go, we have 5, 6, 6 cannot go, we have 8 cannot go, we have 10, we have 15, and we have 30. That is simple, maybe we just have 30. Now, after writing the factors, you have to look for the common factor of what? 12 and 30. Which numbers are common? Which number is found in this set and also found in this set? We have 1, we have 2, we have 3. What else? We have 2, we have 3, we have I think that's all. Yeah. So we have 1, we have 2, and we have 3. Not so. Let's see. 6. Hey, be careful. 6 is a factor of 30. 6 is a factor of 30. So we also have 6, and that's all. Now, these are the common factors. You now ask yourself, which of these factors, which of these numbers is the highest? The highest is 6. And you can say, hence, the HCF of what? 12 and 30 is equals to 6. Okay? That's it. Now, using method 2, which is a tabular method, you start by writing out the numbers 12 and 30. Now, what do we have to do? Same process. Start by looking for the numbers that 12 and 30 can divide with that remainder. So you can always begin with your 2. You can always try prime numbers beginning from 2. Okay? 12 divided by 2 is 6. 30 divided by 2 is 15. Is there no number that 6 and 15 can divide with that remainder? Yes. So what do we have? 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. At this point, this is the difference between LCM and HCF. Go back to the notes you copied initially when we were doing the tabular form of LCM. Compare. At this point, there is no number that 5 and 2 can divide with that remainder at the same time. Okay? So at this point, we have to just end and we pre-multiply this. And that is the HCF. Okay? So at the point where these two numbers, where there's no number that exists, that these two numbers can divide with that remainder, you just end the process and pre-multiply it. So hence the HCF becomes what? 2 times 3, which is equals to 6. And that is our answer. So you see that here we have the same answer, and here we have the same answer. So thank you so much for watching and stay tuned. If you haven't subscribed yet, make sure you click on the subscription button and subscribe. Make sure you like, make sure you share my videos to your friends, make sure you comment, and so on.